Welcome to PragmaDev Testing Tool presentation and demonstration. We will first go through a general presentation of the underlying testing technology and then move to a tool demonstration on a simple example. PragmaDev Real-Time Developer Studio is based on TTCN3 International Standard. TTCN3 stands for Testing and Test Control Notation. It is written by ETSI and standardized by ITU. TTCN3 is a textual language that includes high-level services such as messages, procedures, timers, and parallel execution. TTCN3 also includes its own data types, the concept of template in order to verify an information in one statement, a test case organization, and the concept of verdict. The system to be tested is called the system under test, SUT. A test case is organized in a control part that controls the test execution, a master test component, and some optional parallel test components. The test case interacts with the SUT through the system interface that defines a set of ports. A port can be asynchronous, like a message, or synchronous, like a function call. The implementation of the system interface is described in this figure. At the bottom left, the outgoing information is generated as a macro call. The user can define the macro call to be any desired action. On the other way around, information coming from the SUT is put in message queue. Each test component is mapped to one of these queues to receive the information. PragmaDev Real-Time Developer Studio modeling technology addresses validation testing, integration testing, and unit testing, as well as specification, design, and code generation, covering 80% of the development cycle. Let's now start PragmaDev Real-Time Developer Studio. We will open one of the examples coming with the tool. It's a simple send request waiting for an answer. Let's have a look at the TTCN file. Two messages are defined as TTCN records. One is called mRequest and the other one mAnswer. Each message has one parameter. A port type is defined that will handle the mRequest message going out and the mAnswer message coming in. A component that uses the previous port type is defined. Two templates are defining the values of the parameters of the messages, 42 for the mRequest, 43 for the mAnswer. Here comes our test case. It will run on the previously defined component. The test case will start a timer and send the request. Please note the name of the template is actually used to send the request. For the answer, an alternative is created. Either the system replies the right answer, or another answer, or the timer goes off, meaning the SUT did not reply in time. Let's have a look at how the adaptation to the SUT is done. First, let us see what the SUT does. In our example, the SUT is just a function that sends back a message. The C function is defined in this C file. Let's see how the interface between the test case and the SUT is done. The generated code will call the C macro rtds ttcn send message when sending through the SUT port. In that case, the user has decided to call the handle request C function in the macro. In our example, this function is actually part of the SUT. Let's now run our simple test case and see how it behaves. The test case has been compiled with GCC, and our model debugger is now connected to GDB and to the generated executable. Let's start a trace to see what happens in the test case. Let's now run the system step by step. First, the control part is started. Then, the system interface with the SUT is created. The only test case of our example is now created. The test case is now started. Before we go further, we will set a breakpoint in the test case. And now, let's run the test case. The breakpoint is hit and the debugger stops. We can see where we stopped in the TTCN. We can step in the test case at TTCN level. The debugger will automatically step in the C code to a new line in the test case. It is also possible to step in the generated C code. Actually, from any line of the generated C code, it is possible to jump back to the TTCN source. Let's now run the test case until the end. The verdict is fail because the timer went off before the answer was received. This is because of the step-by-step execution we did. We should have used the discrete time mode instead of the real-time mode. Let's now run the test case without any debugger to see how that would execute on a real tester. We will execute from a DOS console. This is the default interface of the generated code. As you can see, the available modules are listed. We will run the control part. We can see the final verdict is pass. This is it for a simple TTCN demonstration. Thank you.